Okay, so my name is Brian Herzog, and I've been with IDEC for a while. I did a previous training last week, kind of covered some standards and stuff like that. But today, what we're going to do is we're going to get into safety relays. What are those types of products? Where can you use them? What kind of applications are they there for that? Why is IDEC unique with this product? We've got a lot of different things that a lot of people might not know about. So that's what this presentation is going to cover today. So I'll try to keep it simple. The other thing is, if you see my picture there, as a safety specialist, I like to go out. That's the fun part of the job, is to go actually see applications. So I'm always an individual that likes commitment to a group effort. Teamwork is what makes it all happen. So at IDEC, we have not just us outside sales guys who used to be in engineering or done engineering related work, but we also have a whole team of inside people as well. So we have people that could do crosses, like some of the relays today, you can cross directly. We have inside teams for that. Obviously, tech support, because when you get into safety, there's a lot of things that require a little extra attention because it's safety. We have also our technical teams, and then we also have like our customer service as well. All this is key to making a project come to a specification or something to go into production. So today we're going to go over that. So let's get started. What are safety relays? So this is what we're going to go over first, and then we're going to talk about force-guided relays. Now, Phil covered this also a little bit in his presentation, relays. The force-guided relays, we're going to get a little deeper into today. I'm going to give you an example of the uses and the connectivity. We'll go over that. The other thing is, I often get asked about, well, what's a safety relay versus a safety controller? Or I might need a safety PLC. There's three different levels of things. We're not going to talk about safety PLCs. Those are really high-end, more complex systems that require approvals. Is this category 3? There's a lot of different things that are complicated. But I'm going to show you an easier method and the difference between safety relays and safety controllers today. So, a force-guided relay, what are they? Well, if you can read here, this is a really good explanation, but it's a relay which contacts are mechanically linked together. So when the coil is energized or de-energized, all the contacts move together, just like a normal relay. However, I'm going to break that down today, and you're going to see that, just like it says here, if one of the contacts became immobilized, no other contact of the same relay will be able to move. We have a guide, an armature, that ties those together. We also have more advanced features called an electromotive force diode in there. And a lot of you are like, what is that? Can you explain that to me? So I'm going to explain that here in the upcoming slides. Okay, the difference between a force-guided relay, well, it's a relay. And then you jump into what we call a safety relay. A safety relay monitors a device, such as a light curtain, a safety laser scanner. It could be a safety interlock, or even as simple as an e-stop. So, it's up to that specific device. If I hit an e-stop and it's one of our competitors and say they have a contacts welded, well, it's the job of that monitoring circuit to find that that device has failed. If I hit that e-stop, it better stop. If it failed before I even stop it, it's the job of that safety relay to detect that. And I've been in some plants where they don't think they need a safety relay or a safety controller. And then they ship a machine or they get it on site. You can't cut corners like that. You have to have a safety relay. For this very reason, when I go into the fenced area or the safety area, that is up to that e-stop. When you press that, it better stop. So the other thing we have is a safety controller, a pre-programmed, a pre-certified device that can actually save you a lot of money. And unlike a safety relay, the relay has mechanical contacts in there, which have a lesser mean time life expectancy. So it has a shorter life because you're opening and closing something all the time. This is where a safety controller can actually benefit because you have a TTL level circuit. So the output is actually a TTL, transistor output. So you get actually, and we specify it, mean time between failures is 100 years. Now, here we got a force-guided relay. So what I just wanted to show you in each of our 3 products that we're going to talk about today, I know it's tiny here, but what you can see up here is what we have is we do have a variety of relays. IDEC's been known for relays for many years. So in particular, when it comes to safety, a relay like this is good because we offer a different variety of a 2-pole, a 4-pole, or 6-pole. Now, if you'll notice here where my mouse is, there is a diode here. Now, a conventional force-guided relay, you could put a diode on the outside of it. And up here to the right, what you're looking at is what is a counter electromotive force diode? Well, really, the answer is in one line here, but basically, when the relay coil is turned off, a high voltage pulse is generated. So, to protect that high voltage, what you want to do is put a diode in there to isolate that. So if you've got an output coming from your PLC to this force-guided relay, say a safety PLC or the safety controller, you want to protect that back voltage. So anyway, we put a diode in there for you, so you don't have to do it. There's nothing external. It's already done for you. This is RF1V series. Now, this is a nice example. If you go back to, I like to say Electronics 101. It's very basic. If you've never done relays before, well, this is a good little simple circuit to understanding what a relay really is capable of. A normal relay will do the same thing as this circuit here. But the problem is, if there was something to fail in a normal relay, say one of these contacts, if you look right here, we're going to talk about relay 2. If one of these contacts were to get stuck or get welded together, say from a voltage spike, you got 120 volts, and then one of these gets zapped, and then you switch in voltage in this count. In this case, I've got plus and minus. All I'm doing is I'm turning the motor forward or reverse. So when I enable relay 1, relay 2, I could turn that motor forward and backwards. Now what happens is if that contact gets welded shut, and I have the other one closed, it could create a problem. A basic short will occur. Damage will occur. That's not good. So the idea of a forward motor circuit, basically if a force-guided relay gets, there's an armature on top of here, and it forces all the contacts to go in one direction or the other. If one of them gets stuck, they all get stuck into the same position. If you look here, IDEC relays, as you know, most of you know, are kind of like a gold-looking color. They're tinted just a little bit. That's unique to IDEC. Now, if you look really closely here, a normal relay won't have this plastic piece, but this is the armature. It moves left and right, back and forth, for the contacts that are down here, whether it's a 2-pole, 4-pole, 6-pole. So in this case, when I have a short, they all short out. I cannot short this motor. This circuit will not short circuit if I use a force-guided relay. Other names, also known as positive guided contacts. You can call it a locked contacts. I've heard it many times called mechanically linked contacts. And then there's captive contacts, sorry. But there's also some people call them safety relays. I don't want to use that. I don't like that term as much because when I refer to a safety relay, even though this is a safe relay, it has some fail-safes in it, but the actual safety relay we're going to talk about today is our HR series. So here's an example of how can you use a force guided relay. Where would I use one? Well, in particular with IDEC products, if I want to expand the safety outputs of, say, a safety relay, in this particular case, let's say I have a safety laser scanner. I'm monitoring the safety outputs. I wired into this guy, this safety relay, but I want to cut off a couple of circuits. Say maybe I have a simple motor circuit, or I have a secondary option. Either way, this picture is just showing you two options. But basically what you have here is you have a dual set off of this safety relay. Same thing with our safety controller. This is a little bit more advanced. And then we're going to talk about this too. But basically, again, same scenario. This is the output of these two things right here, firing the power to these relays. And then you have additional contacts. Also, EDM, it's an external device monitor. If you get a relay, like in this example, a 6-pole, the 6 set is a normally closed contact. So it knows the position. So you can feed that back to the safety circuit. So in addition, you can monitor these safety relays, whether one has failed or not, because the logic knows which way the position of these relays are supposed to be, either energized or de-energized. Now, safety relays. So, these are different types. So HR1S AC is a very simple one. I like to use the AF version because you got two normally closed inputs that you can have, which is a typical e-stop for double redundancy for category 3 or 4 circuits and interlocks. Very simple. And then you jump into the magnetic type. That is a DM, magnetic. And then you have ATE, which is basically the same thing as the HR1S-AF. The difference is it does have a time delay. So I like these relays because they're simple. If you're not a big old programmer, or you're not used to programming safety PLCs, this is your option right here. And you can put in a relay. So you got an e-stop, you can wire to one relay. You've got a safety laser scanner to another one. You can AM these together, whatever the outputs. There's a lot of things you can do with these. These are flexible. It's just a relay. It's very simple. Down here we have the HR2S, and that model is simply for a light curtain or a safety laser scanner. More and more that you see, what you're seeing is in the market is people switching to safety laser scanners because you got zones that you can have. They're a lot more flexible than a light curtain. Light curtains are you got to line them up. They're getting, when you get above a 4-foot length, they get expensive. In some real dirty environments, they may be okay, but a lot of people are switching to safety laser scanners. So in either case, they use the same safety relay. So this safety relay right here can accommodate your existing light curtains that you may have, but you want to install an additional safety laser scanner, you'll buy another one. So either way, you can mix different brands with this product. Now, how does a safety e-stop wire to a safety relay? Well, in this example, we've got HR1S-AF, and it's pretty simple. I like starting out with the basics. You look at this drawing or you look at the manual for a safety relay, and wow, it gets complicated. What is K? What is S? What is everything? Well, I'm here to try to make your life a little simpler because if you really look at it, you have to look at a safety relay. What features are you really going to use? Are you really going to need 3 sets of contacts? Or are you going to only need 2? So, we have other features that we'll talk about in the safety controller that you cannot get from a safety relay, more advantages. So, but in this case, what we have is a simple e-stop. This is our safe break e-stop. It's a very, I would say, one of our top sellers. It's a lockable e-stop. It's not a lockout tagout. Keep that in mind. You still got to lock out, tag out your machine, but this can accommodate up to like 6, 7, 8 different types of combination locks. But in addition to this, in this example, this particular model has 2 normally closed contacts available. S11, S12, I'll feed back into the safety relay. Same thing with S22, S21. That's it. Now, how does that work? When I have this e-stop and I push it, it is the job of this logical circuit to not allow this output to occur if it's failed. Let's say I push that e-stop in, but one of these contacts is not opening, okay, or they're different. So if you have one normally closed, one normally open, in the event that it's going to recognize that. And so it's the job of this safety circuit not to let the machine, that's its job is to see a failure. What we're actually doing is we're actually putting a frequency through, like a time pulse through these contacts. And if anything is off or different, it knows it's failed. This product has failed. Now, how do you use it with a safety laser scanner? Don't be afraid of safety laser scanners. They're actually very simple. Tomorrow, I'm going to be doing a deep dive. I'm going to tell you how to program a safety laser scanner step by step. Even after these videos are going to be mounted or posted on, they will be posted on YouTube. You're going to be able to look at that presentation and be actually set up your own safety scanner. With this presentation, you can actually buy this particular safety relay with our scanner and hook up a little power supply and make your own circuit so you can play with it. The job of this safety relay is to monitor the 2 most important features of a safety laser scanner or a light curtain. Keep that in mind. They have the same outputs. The outputs are called OSSD, Output Signal Switching Device. The little guy over there, if you see him there, he's saying, don't forget that, because it's easy to forget. What is OSSD? Acronyms, I can't stand them sometimes because, when I'm reading something, I don't have to jump off and Google what that acronym means. So that's why I put that here for you. For those that don't use it very often, this is a very common term, a very common abbreviation for the safety output. So if you didn't know that, we have 2 wires on ours, depending on how it's configured. If it's standard configuration for this, you're going to have a yellow and red wire. You're going to wire that into the safety relay. So this scanner, if it goes bad, or one of these outputs, let's put it this way, it's almost look like this. If I had 2 voltages coming out of, I got output 1, output 2, in this case, OSSD 1, OSSD 2, and one of those TTL levels goes a little less than the other one. The levels are not the same. If the outputs are not exactly the same, it's the job of this safety relay to detect that and not let that machine run because this device is bad. So you've got something. It's kind of like somebody in the background always checking over, always double checking your safety circuit. Very important to have this. You don't have this. Some people run this safety or the OSSD, the safety output, directly into a PLC. That's a big no-no because the PLC doesn't know. It's not monitoring. It's just looking for an input. It's not monitoring these outputs. It's very, very important to have a safety device such as a safety relay. Now, that's me in the middle. I'm going to get into safety controllers. What are they? A lot of times, I don't know what a product is. When I first started at IDEC about 6, 7 years ago, I was overwhelmed. My boss actually threw me a switch and he says, "What is that?" And can you explain it to me? Because I knew everything about PLCs and HMIs. At least I thought I did, right? I left that switch and I said, well, it's like a light switch. You flip it up, it goes on. Flip it off, it goes off. What else can it do, right? Well, boy, was I wrong. All these years later, I'm still learning. We have over 14,000 products. And let me tell you, every day is learning for me. If I don't understand something, I build something to make it work. I want to understand it. So this is me and trying to wire it up at home. After hours, I built this box. Somebody says I got a cell tower and I want to be in Russia and know where my cell tower is. Is the propane tank empty or not? It's in the middle of the Appalachian Mountains. And I thought, wow. Oh, by the way, Brian, we want you to have this talk to a SCADA system out in California on a big main screen panel, sort of like at NASA when you've got a big screen out there, you got somebody sitting there watching them, and they want to know where that cell tower went down and why. Oh, by the way, we want a camera. So I built this demo. I figured it out. And IDEC is very micro-sized, very cost-efficient, and our competitors couldn't do it because I went in with my active demonstration, and I proved to the customer this is how it works. As you can see there, I can be remotely, I can send emails, I can do a lot of things. And then you got to ask, well, how does that got to do with safety? Well, what if somebody broke into the little box on the side of the cell towers? There are other things happening that we can do with our HMIs, with open web servers and such. But also, in addition, we can have safety, e-stops, emergency e-stops that have to be placed remotely in the most primitive areas. And we were able to accomplish this. So the safety controller, I've sold hundreds of these. And some people look at it and, it's a pre-programmed device. And that's something that we're going to show you right now. We're going to show you the basics of it. But this output can also tie back into the inputs of your PLC to extend the data. So right now, the way we have it, we have monitor outputs. So say you have a safety light curtain, well, you wired into this device, but now all your outputs are used up of your light curtain. Well, we have, in addition to that, monitor outputs that you feed to a PLC. And the PLC can do whatever you want. It's unbelievable. Tomorrow's presentation, I kind of go over that with a safety laser scanner. And we'll show you how you do that remotely. As of right now, we have 24 logics in the one. They both look the same, and 11 in the other. This is only $523. That's list price, guys. Think about it. Here's why. It saves you money. So, first of all, you have simplicity. No more overcomplicated wiring, and it's pre-certified. Pre-certified, we do all the work for you. When we get a program put into, again, these are programmed by a dip switch. You set it up with a dip switch, and you'll see that in the next slide. But what we do is basically we make your life simple because it's pre-certified. Okay, it's a pre-certified safety circuit. Category 4, Category 3. We have both of those approved for this product. It's a quick setup, so you just hit a switch and you're done. And then it's a small enclosure. Think about this. I've had this. This is a big seller. So I've got 6 safety relays, one monitoring these different devices here. Let's just say here, 2, 4, 5. We got 5. We have 5 here, okay? Each one of these devices, say they have a timer, each one of these would have to have a safety relay for Category 4 circuit. And let's say a PLD level performance level, okay? That's pretty good system. It's really safe, but in that scenario, look at all the wiring you would have to have. Seriously, this is all out of ands and OR gates. What engineer wants to sit there and spend time designing a circuit like this that somebody's going to have to go back and wire? How much wiring is that? Also, if I have a stainless steel enclosure, which I've had this before, what happens when I have to buy a big stainless steel enclosure for $8,000 more when it could be much less? Because this is a very small product. It's very thin. You rip out all this logics, you rip out all your time, you simplify your electrical panel, you make it smaller, you've got a product that's very successful. Now, what about multiple brands? I've had some, I don't run into it too much anymore, but I still run across it with some manufacturers say you have to use our safety relay with our safety product. Well, not with IDEC. You can have one brand, all right, IDEC, connect to multiple different brands of competitor products. So if you're integrating an existing safety system, this is the product for you, whether it's an MRO, which is a end user, manufacturer, or an original equipment manufacturer. You're building, designing machines. This is the product for you. It also requires less power. So you can smaller the power supply on this thing. Think about this. I've also been asked, I'm limited to 6. No, you're not. The safety output of this one feeds to safety input of the next one. I have one customer that has no programming in their PLC. They tied into an existing safety circuit, but they had 12 or 14 robotic work cells. And guess what? We were able to achieve that with the safety controller. 14 different ones of these. Outputs go into inputs, and it goes back to the main controller and success. Now, inside there, this is kind of my last slide. I don't want to scare anybody away, but this is a very simple, to me, it looks simple because the ands and OR gates, if you're not familiar with that, give me a call. I can usually help you with this. It's not my job to do risk assessment. I am trained in risk assessment. I understand it very well. It's very complicated. I don't do it enough to really be able to say, hey, yeah, I can't give advice. But what I can do is I can recommend kind of the direction of which program we would have. Do we have a logic circuit that's pre-programmed and ready to go for you? Majority of them all use what they call an AND gate. Now, if you're not going to use all these circuits, let's say, like if you see here where I put these crosses, I don't want to use all 3 of these. I just got an e-stop, a safety interlock for a door guard, and then I've got inside the robot, I've got a safety laser scanner. This is a typical circuit I see over and over and over. So how that's accomplished is I've got my 2 normally closed contacts right here, T0, X0, or X1, T1. You just wire them directly, just like I showed you in the other slide, just like the safety relay. Same thing with the safety interlock. It has its own channel. Now, we are monitoring these channels. That's it. Those are the inputs. Now, the light curtain or safety laser scanner, they both use a PMP type output. You're going to wire them to this dual safety channel. I know it's a little hard to see here. It's a little small, but if you can imagine this in an AND gate. So all 3 of these circuits must be ANDed. And here, you'll just you're going to put a jumper across these 2 because you're not going to use them. Unused inputs, you can jumper. The rest of this, the way this works here, this OR gate, what this is a simple start button. Every safety device, you have to get out of the way. If I'm inside the robotic work cell, I don't want somebody just, I have to get out of the work cell and then back to the operator station and push a start button. Typically, it's a blue button. That will start the machine back up if all the conditions, all these input conditions are met. An additional, you can push that blue button all you want, but you can have, this is why we have an OR gate, you can push just a button, or you can push a button and have a controlled start, which is an output from the PLC. The PLC has to give the okay. And this is typical if you have this section of machine inserted into your assembly line, and you need to go ahead from the previous machine before this one can start. Okay, so all this is built into this safety circuit. We also have EDMs, which is, your external device monitor, which basically we can run one of our force guided relays or a safety contactor. All that means is the auxiliary contact that we just learned about earlier with the normally closed contact. we know the position. Now, how does all this work? We've got 4 outputs here. Well, yeah, but really we got 2. So unlike a conventional safety relay, it may not have a timer. But if you want a timer in addition to an output, it's already built in. That's what this timer is for. So here's how this works. There's a dip switch. You select a program like this that you want. You set the dip switch. There's a little enter key. There's a little tool that comes with it. You push and hold it in for a few seconds and then release. It's done. Now, that loads this program. The second set of switches here is your timer. So if you want a delay off, you can have a delay off. It's pretty long, but you set the delay here, and then again, you'll just press the enter key a second time, release. Now you've got a completely pre-certified, pre-programmed safety device. This is a great, great product. Now, that's all I have for you today, but I will look and see if we got any questions in here. If you guys got any questions, please let me know if you have any. I'm going to look here. Questions. I don't see any. Hold on, wait. Let's see. Okay. All right, let me see here. I got to expand the question box here. I'm trying to. Okay. Okay, so am I able to access other? Okay, this product, basically, am I able to access the other product webinars that you will be able to. Product webinars, we will be sending out, and I haven't seen them posted. They're supposed to be up there with the PLC and HMIs. As of right now, I haven't seen them posted yet. We should be posting all 9 videos. I think we have between 6 or 9 videos. I don't remember. But yes, you will be able to access those. Okay. Let me see what else you got here. Okay. Trying to expand it here. Bear with me. Okay. All right. Okay. All right. Let me see. Going through the questions here. Yes. Somebody also is wanting to know if this will be emailed to us. We'll be sending you a link, and we will be posting these on there. It's definitely something we want to get out. I will push them to get that out as soon as possible. Yes. So let me continue here. I got a lot of questions. Let's see. It seems like some of you are really wanting to know where the presentation materials are. Well, we just launched our first of all, let me back up. Individual materials that I use to make this presentation are all on the website. But as far as the presentation, those will be on YouTube. So we'll make sure that we get that up and out. My email is brian@idec.com, IDEC.com. It's Brian with an I, BRIAN @idec.com. If you don't receive something the next day or two, hit me up, let me know, and I will definitely get back to you as far as the link. There should be sending that out to everybody that's logged in here. I appreciate everybody's compliments. Yeah, I thank you. I really enjoy doing these. Can you use regular relay? Okay, we got another question here. Let's see. Okay, they want to know, can you use a regular relay to input to a safety relay? I'm not sure if you're Bob. I think you're asking about the just using a regular relay. Well, I don't. I mean, the whole idea of a safety relay is to. I mean, I guess you could. It depends on if you're talking about a force guided relay. That's a little different. You're just turning it on and off. If you're talking about a regular relay going to a safety relay like our e-stops, mm, not really. That doesn't make sense because the contacts have to physically open and close at the same time, and that's the difference with an e-stop. We have ratings that guarantee that they become depressed at the same time. They have to be engaged or basically normally closed, need to open at the same time or close to it. A relay, having a relay going to a safety relay, that might be a problem. I might need a little bit more information from you on that, but as far as that's probably not going to work. Uh, let's see. Are the safety relays both 24 and 100 volts AC? So we do have some, I believe, AC. As far as the range, I'll have to look. I know they go up to 240 volts. As far as 24 volt, yes, we do have those. I don't think in my presentation that you all are looking at shows it. Well, here, this, I think you guys are seeing my screen there. Yes, so 24 volts AC or DC. Yes, we do have those. Okay, let's see. We got some bunch more questions here. I'll keep trying to look at them here. Okay. Okay. It looks like, guys, it looks like we've got any communication protocols like Ethernet. Um, Al, this is for you. Basically, with the communication protocols, as of right now, no, that is in the works. Right now, a safety relay is obviously we won't have protocols because that's the idea of that is to cut cost and to use in a basic application or up to six. That's safety relays. The safety controller is a little bit more advanced, but as of right now, we do not have that Ethernet port you're looking for to do advanced protocols such as the FlexSoft or the Ethernet IP, which is most common. Right now, we have the monitor outputs. You physically wire it to your inputs of your PLC. That's how we extract that information with that, but not on safety relays. All right, some there. All right, so are these relays used in the pipeline operations and in robotic cells? Okay, I'm not 100% sure I understand the pipeline operations, but depending on what that is, I've seen it a lot. And yes, you do have these, many of these. As far as the safety relay, oh wait, are the relays used in the pipeline? Okay, so the relays, I see some used with robotics, but most of those are the safety controllers in particular that I've seen. Just because of the flexibility of it, the meantime between the life expectancy of it's much better than any safety relay out there. So instead of a typical 50,000 operations, you're going to get 100 years out of because it's TTL level. Now you would use the relay on the output of that if you want to extend that. So as far as in the pipeline, I don't understand. We may have to talk about that a little further. Okay, so we got a lot more questions here. Keep them coming, guys. I'll see what I can do to answer them the best that I can. Uh, Here, I need to expand this apparently. Mm, see, okay, here it is. I see now. What is the difference between a dual channel direct input and a dual safety input on the safety controller? Okay, so I think what you mean, the dual channel direct input versus a dual safety input. Okay, so basically on this one, this is Glenn's question. If what's the difference between the dual channel direct and a dual safety input on a safety controller? The safety controller basically offers a dry contact. So there's two sets. We'll have a secondary one like you saw for the light curtain, and that here. Let's take a look at this real quick, and it'll explain it. So let's see, safety controller. Okay, so if you look at my circuit here, you'll have a dual safety input, which is it's basically an OSSD. That's the right way to say that. It's an OSSD 1 and 2. It's a PNP. It's a transistor logic output. It's the same output you get on the safety controller. So the input's the same as the output. On that, basically you wire it to a light curtain or a safety laser scanner. The dual channel direct input is for basically an e-stop or a set of dry contacts, what I call dry contacts. Okay. Okay, somebody's explaining now what they mean by pipeline. So a motor, okay, for those of you like me who didn't really understand pipelines, it means a motor control centers, motor starters, like for 250 horsepower motors, safety controllers to protect the power circuit. No, these really aren't for, the only thing that I can say that we can do is monitor auxiliary outputs of a contactor. So you may have a starter motor, but you want to feed the EDM, the output of that, back to the EDM. Like in this drawing here, the safety controller in particular, if I have where my force guided relay is, like that, like in the example I gave earlier with the normally closed contact, we can monitor that feedback. Now, as far as the motor, no, we don't really, the idea of the safety controller is really to monitor the input. You don't want to put it's more of an EDM, so we're not really set up for motors. Okay, other question, let's see. All right, we got a lot more questions here. Keep rolling in. Okay, let's see. Okay, so this person wants to know, are there levels or ratings for safety devices like safety relays? If so, how do you choose the right safety level and device? Again, are there safety levels or ratings for safety devices like safety relays? If so, how do you choose the right safety level and a device? Okay, well, first of all, there are categories. You can have a category 2, 3, 4. Typically, people want a category 3 or 4. Just because the number's higher doesn't always determine the type of level. You have to, safety is very complicated. There's, like my previous presentation showed, like there's a lot of standards. So to answer this question, how do you choose a safety level for a device? It's really a risk assessment. You have to look at, like for example, if I have a press with a die in there and I stick my hand in there, well, typically you have to put the light curtain back so far. There is actually a ruler to measure from the point of contact to the distance, and you have to consider the delay in the circuit of how long that's going to be. So to answer, there's really, to determine which one of these you want really depends on the application that you're looking at. There is no easy answer to that, other than the fact that, safety relays, typically category 4, comply to many of the PL levels, the performance levels that need to be required. There are softwares out there that that help you with that, and that's something that IDEC really can't recommend, but I can, um, you know, to you just have to individually look at the circuit. But typically, category 4 is the one you would want. Okay, so the operator or contact falls off the push button and normally closed. Let me see here. Okay, so if the operator or the contact falls off the push button, will the normally closed contact open? Yes. So this is, I should say yes, only to our safe break e-stops. If you look in our literature, we have a dot in our brochure, but our XN or XW series are our most popular ones. If the contact block falls off the back of that, we have a thing called safe break. And in addition to that, the way we use a reverse energy mechanism and the way the springs are, we actually force those contacts open, regardless if the contact block falls off. But yes, if it comes detached, somebody hits it with their belt or something like that on a machine, yeah, absolutely. Some of the best e-stops in the world are made by IDEC. They really are. They truly are. In my last presentation, we kind of went over that. So make sure you get to watch that. Safety Products Introduction is what it's called, and you'll want to see that. And Wayne confirmed that this has happened before. Yes, Wayne, I've seen guys even hack the lockable e-stop. They actually cut the thing to get the lock off of there. So I don't know why people do weird things. And in the event, like our competitors build a cheaper product, the plastic is literally cheap. And you put our e-stop on there, and its contact block falls off. You will have a safe break action occur, and we will force the contacts open. Very, very safe. Very unique to IDEC. Okay, so we've got another one. Okay, Jerry, been a while since I've talked to you. Let's see what you said here. All right, to answer the question on motor, I use horse. Okay, so according to Jerry, okay, this is in regards to the pipeline or the motor control. He's saying that you can use this person's used a force guided relay to drive position driven contacts up to a certain current. The force guided relay is controlled by the safety monitoring relay and EDM of the force guided relay and positive driven contactor to safety monitoring relay. So it sounds like that's something you can do, and I believe this is a question Bob had earlier. Bob, I'll have to get some clarification on this for sure. All right, let's see. Let's see, levels. All right, guys, I think I've just about answered all of these questions. I'm going to cut the meeting off. Again, if you got more questions, please feel free to do so, but we should have our presentation up on YouTube. If you don't get that link, just let me know. I'll be happy to make sure we send out an email again with the products instead of just the HMI PLCs. All right. Thank you, guys. Much appreciated. And you're welcome, all of you. Have a good day.